fights in the fight. 3 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 fights in the fight. Fight blue and white. 3 fights in the fight. Fight blue and white. 3 fights in the fight. Fight blue and white. 3 fights in the we're gonna fight every test, every trouble, every mess, every rumble, every pen, every paper, every right, every answer, every win, every loss, every circle, every cross, every piece, every wall, every wound, every scar, every chicken, every fork, every spoon, every fork, every color, every hue, every red, yellow, blue, every darkness, every light, for the blue, for the white, everyone, every day, every fight, one big fight.
Radyo, 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 Katipunan. Radyo, Katipunan. Radyo, Katipunan. Radyo, 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 Katipunan. Radyo, 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 Katipunan. Voice of the Blue Eagle, kami di mapipigil sa pagbabalitang tumpak at tama. Buhay atin sa labas ng eskwela, ating ibibida lahat ng eskwela. Radyo, 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 Katipunan. Radyo, 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 Katipunan. Radyo, Katipunan. Katipunan. Kawan ni Ignacio, Katipunero, sugod, todo sa kayod, punong at tulong. Lipat na Blue Eagle, galing hiting at tigil.
Be inspired, be guided, be blessed. Campus Ministers on Air is up next on Radyo Katipunan 87.9 FM.
Radyo, 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 Katipunan. Radyo, Katipunan. Radyo, Katipunan. Radyo, radyo, Katipunan. Radyo, Katipunan. Sa Blue Eagle kami di mapipigil sa pagbabalitang tumpak at tama. Buhay ating isla sa loob sa labas ng eskwela, ating ibibida lahat ng eskwela. Radyo, 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 Katipunan. Radyo, 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 Katipunan. Radyo, Katipunan. Katipunan. Kawan ni Ignacio, Katipunero, sugod, todo sa kayod, tulong at tulong. Lipat na Blue Eagle, galing giting at tigil. Blue and white, one big fight. Radyo, 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 Katipunan. Radyo, 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 Katipunan. Radyo, Katipunan. Katipunan. Radyo, 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 Katipunan. Radyo, Katipunan.
And there was another drive-by shooting.
The fire we reported at Loyola Fire Hall is still burning out.
Do you sometimes feel confused or lost in the complications and complexities of life? Do you feel drained, listless, or exhausted from the daily burdens and responsibilities? Why not seek our campus ministers on air every Tuesday from 2 to 3 in the afternoon? Listen to our counselors from the Loyola School's Campus Ministry Office as they ground our lives in our faith, in our school's spiritual tradition. Campus Ministers on Air. Be guided, be inspired, be blessed. Listen to our Campus Ministers on Air.
A grace-filled Tuesday afternoon, friends. Welcome to the Campus Ministers on Air, the radio program on the Office of Campus Ministry, where we try to find God in anything and everything under the sun. I'm Vincent, your campus minister for Freshies. And so we begin our episode today with a prayer. Let us be reminded that we are in the most holy and loving presence of the Lord as we pray. In the name of the Father, the Son, the Holy Spirit. Amen.
Every day I sing to you with all my heart. Hear my prayer, I raise them all into your hands.
Come to me and keep me safe in your arms. Strengthen me to face the day, for you I stand.
Even if the sadness stay with me, and fill me with your joy endlessly.
Lord, help me understand to follow your commands. I entrust my life into your care. My Lord, fill me with your love, fill me with your truth, fill me with your kindness. My Lord, let your goodness shine, let me speak your truth, let me be the bearer of your love.
Every day, let me proclaim and testify in your word. Show me your way, for you are light.
You alone can bring all wonders in this life. Heal all wounds and take all worries I hide.
Even if there's darkness, stay with me.
And in your hands I hold faithfully.
Lord, show your grace inside. Grant me what you desire.
I raise all my voice, Lord, sing with me.
My Lord, fill me with your love, fill me with your truth, fill me with your kindness. My Lord, let your goodness shine, let me speak your truth, let me be the bearer of your love. Fill me with your love, fill me with your truth, fill me with your kindness. My Lord, let your goodness shine, let me speak your truth, let me be the bearer of your love.
Let me speak your truth, let me be the bearer of your
Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginnings, now, and will be forever. Amen. The Father, the Son, the Holy Spirit. Amen. So today, our episode is all about the question, why is there something rather than nothing? And we invited Lord Martin Rees from the University of Cambridge to discuss with us the question and try as much as possible if we can answer the question itself. And so, please watch the video. Good afternoon, everyone. The topic this afternoon is the question, why is there something rather than nothing? The question of ultimate origins. Now, the question, why is there something rather than nothing, is one of the most difficult and enduring questions in philosophy. The German philosopher Martin Heidegger describes it as the fundamental question of metaphysics, a question that touches on the very fundamental nature of existence itself. Since the time of Aristotle until today, it continues to torment and bedevil philosophers, scientists, and even theologians. What happened before the Big Bang? What caused it? What happened during the first moments after the Big Bang? All these questions stand at the intersection of philosophical, scientific, and theological explorations. Today, with the progress of modern science, is it possible to finally resolve and answer these problems? Or is it still a long and difficult road to travel? With us to discuss the question, why is there something rather than nothing, is Lord Martin Rees. Lord Rees is the Astronomer Royal of the Royal Households of the United Kingdom and a former president of the Royal Society. He is a former master of the Trinity College and an emeritus professor of cosmology and astrophysics at the University of Cambridge. He is also a member of the House of Lords of the United Kingdom. He has written a number of books, including Before the Beginning, Our Universe and Others, Our Cosmic Habitat, and If Science is to Save Us. So, brothers and sisters, let us welcome Professor Martin Rees.
Thank you very much for inviting me to join you, and good wishes to you all.
Thank you. Thank you, Professor, for saying yes to our invitation. No? So, before we start discussing the question, kindly tell us, Professor, what is your main job as the Astronomer Royal of the United Kingdom? What is part of it is your interest? So, could you tell us what is your job and your interest, Professor?
Yes. Well, I should say that being Astronomer Royal is really an honorary position. People used to ask me, did I do horoscopes for the Queen? I have to say she never asked me, and also I had to say that I'm not an astrologer. I have no crystal ball. I'm just an astronomer, and astronomers don't have always the right answers. They don't always make the right predictions. All I would say in their favor is that astronomers and other scientists do a better job than economists in making predictions.
Yes. And your interest, Professor, I mean, astronomy is a big, it's a big field, no? So what is your main interest, specific interest?
Yes. Well, let me say I spent most of my career at Cambridge University studying astronomy, and I'm mainly a theorist, and I've been trying to make sense of the wonderful stream of data that's been coming from telescopes on the ground and in space at an increasing rate in recent years. And so I've been trying to understand really how objects like stars and galaxies came into existence, how they evolved, and how the Earth formed, and what its fate will be in the future. And of course, as you said in your introduction, to try and go back as close to the beginning as possible to understand how our universe emerged and what it was like in its early stages.
Yes. And with that, Professor, where are we in our quest for the origin of the universe?
Well, I think if I look back in my working lifetime, which is more than 50 years, there has been huge progress in that we knew already 50 years ago that the universe was expanding, galaxies are all going further away from us, which suggests that they were closer together in the past. But back in the 1960s, when I started, there was a big debate centered actually in Cambridge about whether the universe had existed forever in a so-called steady state. This was the idea that although the universe was expanding, maybe as the galaxies moved apart, new ones formed in the gaps, as it were. This was an idea which Fred Hoyle, who was one of the leading astronomers at that time, advocated. And that was a conflicting idea to the alternative, which was that the universe started off in a hot, dense state and had actually evolved, and that it did have some sort of beginning. Now, in the 1960s, there was firm evidence that emerged that the steady state theory was not correct. It came from evidence that in the past, and of course, when you look a long way out in space, you look a long time back in time, and it turned out that things were not the same then as now, so there was evolution. And to fast forward to the present, we now can talk with confidence about how the universe, in its broad outlines, has evolved from some very early time. And we can go back to a time when the universe had been expanding for only about a millionth of a second.
Yeah.
A millionth of a second. After that time, we roughly understand how its density fell off, how it cooled down, and when galaxies started to form. And we have evidence for that. Now, that may seem almost the complete answer, but of course, you should think on what we call a log scale, and what happened in the first microsecond was very, very important, and that's not understood. And so the fact is that now we can push things back to about a microsecond. And the reason I say a microsecond is that as you go further back in time, then everything gets hotter and hotter, and the particles move around faster and faster and more energy. And when you go back to a microsecond, all the particles are moving as fast as the fastest we can produce in an accelerator in a lab, these big accelerators. And so back to that time, we have some foothold in experimental physics. But in the first microsecond, conditions were far more extreme than we could ever achieve in any existing laboratory. And so that's why that becomes uncertain. So there is a mystery, but that's been put back into the first microsecond.
And of course, Professor, the key element here, that proves that the universe, had a beginning is the cosmic microwave background radiation. So could you tell us what is that all about?
Yes. Well, the evidence for this is twofold. First, we can now look out deep into space, especially with telescopes like the James Webb Space Telescope, to a time when the universe was about 3 or 4% of its present age. And when we look at galaxies out there, they are plainly very different. It's clear that the stars in them were younger and that they had recently formed. So we have evidence of that kind, that the galaxies were starting and they looked different back then. But then you mentioned the microwave background, and this is what's sometimes metaphorically called the afterglow of creation. And this is a discovery that was made accidentally by two radio engineers in 1965, which was that even intergalactic space isn't completely cold. It's warmed to a temperature of about 3 degrees above absolute zero. And that radiation is left over from the early universe. It fills the whole of space. And so the story we now have is that as we extrapolate back into the past, the universe would be more compressed, and the radiation in the background would be in the form of higher temperatures. So it would be more compressed and higher temperatures, and the further back we go, the hotter it would be. And we can therefore work out roughly what the material would have been like at different times. And for instance, we find that at about 300,000 years after the beginning, the temperature would have been a few thousand degrees. And that's important in physics because that's when the material, the atoms, become neutral rather than ionize. The electrons stick to the nuclei, and that makes the universe change from being opaque to being transparent. And so we can actually look at individual photons in this background radiation, which have come to us unimpeded since the universe was only 300,000 years old. And so we have some evidence of what the universe was like then. And we can go back further still, because one of the things that would happen when the universe was about a minute old is it would be at a temperature of several billion degrees, and the atoms would undergo nuclear reactions, which would turn hydrogen to helium, etc. And if you apply standard physics, you can calculate what the composition of the material will be as it's cooled down from this beginning, being processed through this era when it was hotter than a star. And the answer is that it would come out about 24% 24% of helium, and the rest, nearly all, still hydrogen, and a bit of deuterium, a bit of lithium, and not much else. And what's wonderful is that that is what is observed. And so we have direct fossil evidence where theory and observations agree, which tell us about what the universe was like when it was just a few minutes old. So that's the big change from not knowing whether there was a Big Bang at all to be able to talk now with a straight face about what happened right back near the beginning.
Yeah. And what about, Professor, I think it is popular now among physicists that they want to discover the theory of everything, no? The unification of the four forces of the universe. So what do you think of that?
Well, of course, that's going to be essential. And if we extrapolate back still further, then we get to a domain where we don't understand the physics, but we are pretty sure that to understand it, we would need to have a theory like that. Let me put this more numbers. At the time when the universe was a millionth of a second old, which is the earliest time we have, then everything we can observe with our biggest telescopes would have been squeezed down to a size smaller than our solar system. But to answer the big questions that you've asked, we have to go back much, much further still, probably to a time when the entire observable universe was about that big, about the size of a tennis ball. And that's an enormous extrapolation to a time when the particles have much more energy, etc. And that's the domain when we would have to take account of gravity on the atomic scale. Of course, in the present universe, gravity is very weak, except when zillions of atoms are packed together to make a planet or something like that. But back at that early time, you have to worry about gravity along with the other forces at those ultra-high densities. And so the answer to your question is there are lots and lots of ideas about what the physics was and what the universe would have been like at these very, very early times. But although there's some evidence for some of these ideas, it's still very speculative. And you need a breakthrough in physics or some completely new kind of experiment to actually test these extreme conditions. And so that's the problem with understanding the very early stages of the universe, that the conditions are very extreme. But almost certainly, as you say, it will involve having a theory which is a so-called grand unified theory which will bring together gravity and the forces of the micro world.
Yes, and somehow some physicists proposed the string theory. Do you believe that, Professor?
Well, I mean, I should say I'm not an expert on this, but string theory is the most widely discussed idea which could explain these things, and there are lots of variants of string theory, but certainly many people have discussed what the consequence would be of particular string theories. But although there are some ideas, there's a concept called inflation, which suggests that the universe had a period of very rapid expansion, and there are some ideas which can explain why that sort of thing would happen. The trouble is that string theory involves very complicated mathematics. One can't really calculate what the consequences would be in our low energy world, so we don't know whether to believe those theories. That's the problem. They're complicated because in string theory, every point in our three-dimensional space, magnified enough, is a wrapped up origami in 5 or 6 more dimensions. So there are really about 10 dimensions altogether, and 3 are the ones that we live in. But space has a granularity, a complex structure, but that's on this tiny, tiny scale where these 5-dimensional structures are wrapped up. So it's a very, very difficult theory, and it may be completely wrong, but that's, as you rightly say, perhaps the most widely studied theory, and has been for the last 30 years or so.
So thank you, Professor. So let's discuss the question itself, Professor. Why is there something rather than nothing? So I remember reading the book of Professor Stephen Hawking. He said that asking the question, why is there something rather than nothing, is just like asking what lies in the North Pole. And for Stephen Hawking, that is a very nonsensical question. So what do you think of that? What is your take on that?
Well, I mean, he was just giving a rather crude metaphor. I mean, I think before giving a specific answer, let me say one thing. I think it's quite possible that the deepest aspects of reality are beyond what human brains can understand. There's no particular reason why our human brains should be able to understand everything. So just as our brains haven't changed much since our ancestors roamed the African savannah 100,000 years ago, and they evolved to cope with the everyday world at that time, it's amazing that they have been able to understand the micro world of atoms and something about the cosmos. But there's no reason to think that they have enabled us to understand the deepest levels of reality. And so it could be that the questions that you're asking in perhaps some different formulation could be answered in principle, but only by a vastly superhuman intelligence. So just as a monkey can't understand quantum theory, so we can't comprehend the ideas that would be needed in order to make sense of these deep aspects of reality. So I think this is my view, and this does indeed, as you say, impinge on philosophy. These are deep issues where we can experience the wonder and mystery, but may never really be able to actually understand or comprehend things.
But do you think, Professor, this is a meaningful question? The way we ordinarily define the word nothing?
Well, it's certainly a meaningful question, but the definition of nothing may become very
different.
And of course, the concept at the beginning may become very complicated because there are certainly some speculative theories where there was not just one Big Bang, but many. And so physical reality is far more widely encompassing than just the aftermath of our Big Bang. And so there are all these ideas about how extensive physical reality could be, which we don't know. And of course, in that context, the idea of a single timeline and a beginning may not make sense. So I think we've got to accept that it's amazing that from knowing nothing about the early universe, we can talk about it back to when it was at a temperature of billions of degrees. We have mysteries which have yet to unfold.
How about the question, Professor? What caused the Big Bang? Is there a popular theory about that today?
Well, no, because that would really have to be understood as a consequence of some physics we don't yet have.
Yeah.
And you say caused, but that would allow us to trace back still further.
Yeah. And I think there are scientists, like Stephen Meyer, and I mentioned earlier Leibniz, and they offer God as an explanation. Are you prepared to accept that, Professor?
I wouldn't understand it. I mean, I think I'm someone who appreciates the social aspects of religion, emphasizing our common humanity when so much divides us. But I don't have any sort of dogmatic beliefs, and the point is, I would not expect an easy answer. I mean, often when I talk to religious people, they say God made the universe. That's our answer, and you argue you don't have an answer. And I would say I wouldn't expect it to be something that we can understand, because for most of us, understanding a single hydrogen atom is pretty difficult, and so it's presumptuous to believe that we can give an answer to a fundamental question like the beginning of the universe. And so a sort of flip easy answer of the kind which some people claim to get from religion is clearly very superficial.
Yeah. And another question, Professor, about the structure of the universe. Do you think the universe is a closed material system, that there's no spirit or souls that we can attribute to it?
Well, here again, we don't know. I mean, we understand the basic forces, and we understand that they allow complexity to emerge. Biological systems which are made of atoms but are vastly complex, we don't know. And I think we should be open-minded about there being other influences and forces which are beyond the capacity of our brains to understand. We should be open-minded about that.
Yeah. How about consciousness, Professor? Do you think that is a byproduct of a mechanism or chemical reaction inside our brain? What do you think about that?
Well, again, we don't know. I mean, it's true that we have a kind of self-awareness, and so do many animals. And of course, this is a question being discussed a great deal, because we now have computers which in many respects can surpass human intellects, and people talk about generalized human intelligence in some electronic entities, and it's a very important question. Would that involve consciousness, and would they be self-aware? Would they have an internal life of thoughts, just as we do as humans? And I think we should be open-minded on that. We don't know. It could be that some kind of consciousness or self-awareness emerges in any sufficiently complex system. It could be, on the other hand, that it is rather specific to the kind of chemistry that we have, and that you could imagine that there are entities which behave in as complicated a way as we do, but as it were, have no inner life, no self-awareness. And to digress slightly, one thing I think about is the future of the universe. We talked about the past, which is about 13.8 billion years, but according to most ideas, the future is much longer. The universe is going to go on expanding for a very long time in most theories. And so one important point, which I think astronomers understand more fully than most people, is that if we, even though we will believe in emergent complexity, that simple life emerged at some stage and by Darwinian evolution evolved into the marvelous biosphere that we see around us and of which we're a part, we should not think of ourselves as a culmination.
Yeah.
Because at the time, the Earth has existed for 4.5 billion years, but the Sun will go on for another 6 billion years before it flares up and dies and destroys the Earth. And so we may not be at even the halfway stage in the emergence of complexity. So one scenario is that more and more complexity will emerge, maybe not by Darwinian processes, but by machines designing even better machines, etc. And that we'll end up, or we would end up business from now with an intelligence which surpasses humans by as much as we surpass a slime mold or an amoeba. We just don't know.
Yeah. So that's a good segue, Professor, because this time we'll talk about life, human life, or life in general. So, what do you think about life? What is the best starting point to talk about life? I mean, Richard Dawkins said that it started with a replicating, metabolizing entity. So, could you talk to us to the process?
Well, I mean, let me first say that it's still a mystery.
Yeah.
We understand complicated chemistry, etc. And once simple life forms, we understand the way in which natural selection can build up more and more complexity, as Darwin first appreciated. But it's still the case that the actual transition from complex chemicals to something we call alive, something which replicates and metabolizes, this is still something which is not understood.
Yeah.
People have realized it's an important problem, and now people are working on it. There are people in the famous laboratory of molecular biology here in Cambridge who are working on this to try and understand it better, and they're making progress, but it's still not understood. And there's an extra motive. First, we know far more about microbiology, and secondly, of course, we have the fascination of knowing that there are many other planets orbiting other stars that may be like the Earth. So the question of whether there is life elsewhere, and whether another planet like the Earth would have developed life, or whether life is some extremely rare fluke, those questions are fascinating, and they're much higher on the agenda now, because in the next decade or two, we could, if life is widespread, find evidence for extraterrestrial life. And then that would tell us, obviously, more about it. Is it all based on the same sort of double helix genetics that Earth life is, or could it be quite different? Does it even need water as a solvent or not? We just don't know. But this is, I would say, one of the most exciting areas in science. And if there are any young people listening to us who are thinking of a research career, then I would say that the exobiology and the origin of life is a very exciting area in the coming decades.
Yeah. And as an astronomer, Professor, do you see evidence of alien life outside?
Well, none yet. And so, well, let me answer in two parts. First, there's a difference between some kind of life and intelligent life. And what's happening now is that we know that most other stars are orbited by a retinue of planets, just as the Sun is orbited by the Earth and the other familiar planets. And so we know that in our galaxy there are billions of planets like the Earth orbiting other stars. And it's possible to make at least crude observations of the light from the nearest ones. And this is being done now using the James Webb Telescope, and there'll be a very big telescope on the ground built by European scientists in Chile, which could be online in 4 years' time. And so if, for instance, there was a planet covered in trees, then the chlorophyll would be detectable in the spectrum of the light from that planet. And so within 10 years, we will have crude spectra of these other planets, and they'll tell us something about it, and whether there could be any life. And this can be done even though these planets are very faint. So let me give you an analogy. Supposing that there were some alien astronomers looking at our solar system from, say, 50 light years away, then the Sun would look an ordinary star, and the Earth would look, in Carl Sagan's nice phrase, a pale blue dot, lying very close in the sky to its star, our Sun, but millions of times fainter, very hard to detect. But if the aliens with their telescopes could detect this pale blue dot, our Earth, they could learn things about it, because the shade of blue will be slightly different depending on whether the Pacific Ocean or the landmass of Asia was facing them. So they could learn that our Earth had continents and oceans. They could learn the length of the day, and they could learn something about the climate and the atmosphere, and there was oxygen in the atmosphere, etc. They couldn't see an image in high resolution, but they could learn some things about it. And observations and inferences like that can be made, I would guess, within the next 10 or 20 years about some Earth-like planets around other stars. This will tell us if they are the kind of places that may have life, and maybe some evidence for that life. There's another different kind of experiment being done, which may answer the question, and that is that there are probes being sent to the outer planets of our solar system to look at two particular moons. There's Enceladus, which is a moon of Saturn, which has ice covered, but there's evidence for water underneath that ice, and Europa, which is a moon of Jupiter, which is rather similar. And there are space probes, a European one and an American one, going to both these places. And what they will do is they won't be able to go under the ice, but there's more water spraying out, and they can analyze that. And if they're very lucky, if there was some life under those oceans, they would find complex chemicals in that spray, and so that's a possibility. And if they did find that, and I'm not betting they would, but if they did, that would be very, very important, because if life arose twice within our solar system, it can't be a rare fluke. So if it arose twice here, then we could confidently say that it would have arisen in 1 billion places in our galaxy.
So does that mean, Professor, that life is not an improbable event?
Well, at the moment, we don't know. It could be a unique event, but if we found it twice evolving independently in our solar system, then it can't be an improbable event, and then we would say that must exist in planets around those stars.
Yeah, okay.
Yes. And now you just to put a footnote to that, you say, well, why am I talking about these outer planets and not Mars?
Yeah.
Because, and the reason I say that is that if we found evidence of life on Mars, it wouldn't be so obvious it had to be an independent origin, because meteorites can bring stuff from Mars to the Earth to Mars. So it wouldn't necessarily prove that there were two independent origins. It could be that there was one event on either Mars or the Earth, and it came from there. But it's not so easy to imagine how life could have got from the outer solar system to the Earth. So that's why the outer solar system is important. But the important point is that we don't yet know whether life is common or not. And as I say, we will in 10 or 20 years know that. But of course, the other question really is, what about intelligent life?
Yeah.
Okay. Of course, even if simple life were widespread, then intelligent life could be rare. I mean, we know how we evolve by various different stages over the 4 billion years of the Earth's history, from the simplest life. But of course, we know there are lots of accidental features, and things could have got stuck, could have, if the dinosaurs hadn't been wiped out, then we wouldn't be here. And so there are lots of contingencies that were fulfilled in order to allow evolution to take the track it did here on the Earth. And so we can't be sure what the likelihood is of simple life evolving into anything we call intelligent. And but of course that's an even more fascinating question. And there are attempts being made to actually keep one's eyes open for anything in the sky that does look as though it's artificial or artifact, and use radio telescopes to see if there's any transmissions coming from anywhere which seem to be unnatural, or that. So there are some efforts, and I'm involved in some of these searches. I chair a committee financed by an American, which is putting money into buying time on telescopes to make these searches and build special instruments. So that's to say that the search for intelligent life is something which is very speculative, but so fascinating that I'm glad that some people are doing it. And of course, we've no idea what to expect, because it won't be the sort of little green men with eyes on stalks of science fiction. It'll be something which may be quite different from us. And like I say, if you think of the Earth, then our civilization is just a brief phase in the history of the Earth, a few millennia, and future evolution with post-humans, not humans, may be quite different. And so we may not find anything at all resembling a civilization like they involved in here. But nonetheless, there could be something. And I think we are sensible to keep our eyes and our instruments open to the possibility of finding something which indicates some kind of technological artifacts, etc. But that's more speculative, and we just can't predict what the odds are of that. But on the other hand, I think we can predict that there will be a better understanding of the origin of life, and also of whether some kind of life exists in other places, on planets around other stars.
Yeah. So before we leave the topic about life, Professor, This is a very fundamental question. No? What is your personal definition of life? How do you define life in general?
Well, I think the technical definition of life is something which metabolizes and reproduces. And if it does those two things, then it's possible to imagine a selection of the favored entities. So you get some kind of evolution and natural selection. So I think that's the generic definition of simple life.
Yeah. And coming to intelligent life, Professor, the question about consciousness is very pressing right now. So what do you think about consciousness?
Well, I mean, again, I think it is a mystery, and I think it is. I think it is very important to try to understand it, because I think many people suspect that there will be machines, electronic machines, which will be able to surpass human brains in many respects.
Yeah.
Because, obviously, with the electronic things, where the signals go much faster than they do in our brains, you can have far more processing power. And you can imagine some sort of purely electronic zombie, which can surpass humans, not just in calculating and things like that, but in more other activities. But then I think it's still a somewhat open question whether something which seems to have human capabilities but is electronic rather than flesh and blood will necessarily have the same kind of consciousness. And I think this is a very important question, really, because when I give talks about this, I make the point that humans are maybe only the halfway stage in the emergence of complexity. We've had Darwinian evolution that's led from simple organisms to us, but there may be future evolution of post-humans that won't be Darwinian selection, probably. It'll be what I call secular intelligent design. It'll be machines designing more intelligent machines. But I think the question of whether they are conscious and self-aware is something which does matter to people. In fact, when I talk about this, some people say, well, it'd be wonderful if these super brains exist, they'll have deeper thoughts and all that, etc. But on the other hand, if they don't have self-awareness, then it would be sad if there were no creatures which could appreciate the wonder and mystery of the cosmos in the way we do. It's a question which does affect the way we react to the sort of scenario I portrayed when we are taken over in terms of state intelligence by electronic entities. Do they have an inner life or not?
Yeah. So now that we are talking about AI or machine intelligence, Professor, now let's talk about the future of humanity with the emergence of AI. What do you think will happen to us in the next 10 years or 10 to 20 years?
Well, I mean, I think obviously AI is a powerful new technology, and it's going to have important effects on the labor market, etc. It's going to replace work of some kinds. It's going to be a way of augmenting and improving work for some people. For instance, doctors can get better understanding of how cancer develops in the lung from a machine that's been able to analyze 30,000 X-rays of different lungs than any human can in a lifetime. So it's going to be able to support lots of the people in their work, and it's already made big advances in biochemistry, etc. So it will certainly help in many ways. But I think it's going to be important that the humans remain in the loop, as it were, and that we don't delegate important decisions to a machine, because if we are diagnosed with some disease or sent to prison or even denied credit by our bank, we would like to feel that we can contest those decisions and get an answer. It's not enough to be told that the machine has decided this and the machine has a better record of success than the humans it's usurped. I think we would like to feel that we can actually question a real person about that sort of thing. So I think we've got to keep humans in the loop. And another bit of advice I'd give is that if you want to be sure that you'll have a secure job for 50 years, then the best choice is to be a plumber or a gardener. Those are two jobs where you can't imagine a machine doing as well as human beings. So it's not necessarily the sort of very sort of intellectual jobs that will be saved. It's often the ones that involve intricate searches, like a plumber looking through a strange house to try and find what's gone wrong. That's the kind of thing that will be hard to replace by a machine.
Yeah. And I remember, Professor, I think it was Stephen Hawking who had a negative view about AI, that later AI or machines will replace us. What is your take on that? Do you have a negative view of AI?
Well, I mean, I think there's some people. I mean, of course, Stephen was never an expert on this, but there are lots of experts now who do think that there will be machines with general intelligence, and that they could, if they weren't aligned in their goals with human goals, could be disruptive and could mess up the entire financial markets of the world and things like that, or destroy us. I don't worry so much about that as some do. I mean, because I think we've got to bear in mind that there's a long way to go. I mean, everyone's been impressed by ChatGPT and all that, how it can have an intelligent conversation and write things. But of course, it does this because it can work out how words and sentences mesh together. It doesn't understand the real things underlying them. Yet it just understands the words. And well, one example of an early generation of this, there was a computer some years ago that won a TV game show with general knowledge, but then it was asked, which is bigger, Mount Everest or a shoebox, and couldn't answer. That's because it understood all the words, but didn't really have a perception of the real world. Now, they can do better now, but still they don't necessarily understand in the way we do the way things relate to each other in the world. But I do worry very, very much about something which I think is quite likely and a serious risk, which is that we'll become over-dependent on complex systems. We already do for sort of air traffic control, keeping electricity grid going and things of that kind. And if we become over-dependent on networks like that, and if the networks are interconnected and cascade globally, and there's not enough redundancy, then there's a severe risk of some breakdown in essential systems, the financial system, the electricity grid over a whole country, things like that. And if that can't be mended within 2 or 3 days, that would lead to complete social breakdown. So I worry very much indeed about the risk of becoming over-dependent. We see minor versions of this, when the air traffic control system fails in the region of the world, or some software failures, etc. And of course, that's without putting in the quite likelihood of malicious cyber attacks, and etc. So I'm very worried indeed about how we will cope with the possibility of the internet or the electricity grid failing because of some fault in the controlling machinery and AI. It's very, very dangerous indeed. So that's my worry. So it's that sort of thing rather than superintelligence that worries me most.
Yeah. And do you think, Professor, when we can create a super intelligent machine, no, it is as excellent as Einstein or Alan Turing or these great mathematician and physicists?
Well, I think it could. It could certainly make discoveries. I think maybe not quite those insights, but if it's fed information, it can. And of course, there's some things which it could do simply because of its speed. I mean, one spectacular example done recently was this machine which could work out the structure of proteins, and it's a deep mind, and it was able to work out the structure of 200 million different proteins, and the person behind this, Demis Hassabis, I know is an amazing person. He made the point that it used to take a PhD student 5 years to work out the structure of a protein, and so this machine has done the equivalent of a billion years of PhD time by being able to produce very quickly the structure of 200,000 different proteins, and so they can do a lot to help us with our science, and certainly in my science of astronomy, large scale computing, not quite AI, but large scale computer modeling has been crucial, because lots of things I've said about how galaxies form from the primordial material and all that, and understanding black holes and all that, this has been made possible by the fact that we can do computer simulations. We can't crash galaxies together for real in experiments, but we can in the virtual world of our computer. We can crash two galaxies together, and then we can make different assumptions. We can do it with dark matter added in, without dark matter, and make other assumptions, and then we can see which of the simulations matches best what we actually see in the sky. And that's how we can develop an understanding of what we see in the sky, by doing models for lots of different options and seeing which works best. And so astronomy, where you can't do direct experiments, is one where we've been aided hugely by powerful numerical simulations. And incidentally, going back to string theory, it could be that the mathematics of the 10 dimensions of string theory are just too difficult for a human being to do in a lifetime. But maybe one day someone will program an AI to actually select one of these string theories, which does actually predict correctly things in our low energy world, like the mass of the electron, the physics of the standard model of particles, etc. So the machines are very helpful to us in doing science.
Yeah. And one final topic, Professor. What are the major problems that human beings are facing today?
Sorry, I didn't catch that.
What are the major problems that human beings are facing today?
Oh, well, a very long list, obviously. But I think one class of problems, which are global problems, are of course those caused by the ever heavier footprint which we are collectively having on the planet.
Yeah.
There's now 8 billion of us in the world, and we're all using more in terms of natural resources and using more energy. And as we know, this is changing the climate by CO2 emission and warming the climate, and also destroying lots of species, irreversible loss of biodiversity, and all those things. And so, controlling these, as we know, there's one of the climate meetings is taking place in Baku next week, and there are regular meetings by the UN on biodiversity as well. So, dealing with those things is a very important problem for the world. I think the problem really is that it's not an immediate threat. If there's something like a oncoming pandemic like COVID-19, then politicians take action and they will do something, what they can, to try and alleviate it. But if you say that some emergent disaster will develop over the next 50 years, which is what we're told by climate scientists and others, then it's hard to energize people, because politicians certainly don't think on that time scale, and most individuals don't really. And so I think a big problem really is to ensure that dealing with climate change by converting to clean energy and not using fossil fuels, etc. This is important, but it's got to be prioritized. And politicians prioritize the short term, and they don't think so much about what will be good in the long term. That also means that the public aren't aware of what the problem is. And so I think that the way we can actually improve things in that respect is to ensure that there are some powerful, charismatic influencers who can persuade the general public of these threats to the climate and biodiversity, and make people care about the lives of their grandchildren when they grow old and all that, and look ahead to the end of the century. And if enough of the public care, then politicians will respond, as they all vote. And so I think we need, since most scientists aren't very charismatic, we need charismatic influences. And in my book, I quote four who are important, certainly to us in Europe. One is the Pope, who in 2015 had an encyclical which had a big effect on getting agreement at the Paris Climate Conference.
Laudato Si.
Yeah. Sorry? Laudato Si, yeah.
Laudato
Yes.
Si.
And of course, he's got 1 billion followers around the world, so he's my first. The second one is our secular Pope, David Attenborough. I don't know if he's known in your country, but he's with TV programs and things. He's made people aware of the natural world and its vulnerabilities. And the third, I'd say, is Bill Gates, who one of the technical people who actually talks a good deal of sense. They don't all talk sense, but he does. And the fourth is Greta Thunberg, who energized a generation of young people. And of course, young people are likely to care more because they will be alive to the end of the century. So that's a long answer to say that we need to worry about ensuring that we don't leave a despoiled and less beautiful and varied world for future generations. We know what we have inherited from generations past, and we shouldn't. It would be shameful if we left a legacy that was not as good as we have today. So that's one class. And the other concern I have is, as I mentioned earlier, misuse by accident or by design of these powerful new technologies.
Yeah.
And if I can mention what I think is my worst nightmare of all, is engineered pandemics. It's possible by what's called gain-of-function experiments to make a virus more virulent and more transmissible than a natural one. And this was done more than 10 years ago for the influenza virus. It could be done for the COVID. And of course, someone of evil intent could create a virus more virulent and transmissible than COVID-19 and release it. Now, who would want to do this? I mean, obviously, no one would. No terrorist with well-defined aims would want to produce some sort of bio threat because they wouldn't know it would kill. But you can imagine there's someone in the world who is an ecology freak and thinks that human beings are parasites and they're destroying the world, so that it's better to the fewer of them, and it doesn't matter who they kill. So one person like that is too many. And I think the serious threat that the techniques needed to produce some biodisaster like that are available in many labs of industries and universities. It's not like building an H-bomb, which you can't do without huge facilities that can be monitored by the International Energy Agency. And so I do genuinely think that we've got to worry about how we can ensure that no one with these strange kind of evil intents can produce some mega disaster. And I think this is going to be very hard to do because all nations would want to do it. But we know that despite nations all wanting to enforce the drug laws and the tax laws, they haven't had much effect globally. And in the same way, I think it'll be hard to enforce effective prohibitions on these dangerous experiments. And certainly not without more intrusive surveillance and invasion of privacy than we're used to.
Yeah. And final question, Professor Rees, what is your message to our students?
Well, I think my message would be that despite all these gloomy issues, science can be our salvation. I think we are better off than earlier generations through the benefits of science, from smartphones to vaccines and all that. And so we've got to ensure that science develops and its applications are benign, and we develop the benign ones, and we avoid the dangers and downsides of ever more powerful technology. And to be slightly more specific, since we talked a bit about climate and environment, I think one of the biggest issues is going to be to close the gap between the global north and the less prosperous south. If the gap between the north and south gets wider, and if the population of Africa, which is going faster than anywhere else, continues to grow and it lags behind, then that's a recipe for a very turbulent world and a very unjust world. So I think one of the main goals for any idealistic person who works in physical engineering is to ensure or help to ensure that the less developed countries, mainly in Africa and South Asia, can get the energy needs fulfilled by cheap, clean energy. Because it would be no good if the northern countries achieve net zero by 2050, if at the same time the global south is still burning fossil fuels. So we've got to ensure that clean energy can be got cheaply, and so that the nations of the south can leapfrog directly to clean energy, just as in Africa they leapfrog directly to smartphones, having never had landlines. So they've got to leapfrog. And so this is something where we need new technology, and also we need some campaigning and some realization that we have an ethical obligation to ensure that the benefits of science are shared globally. It's an ethical obligation, but it's also in our own interests, because that's the only way we'll get a peaceful world.
Yeah. So thank you so much, Professor Rees, for this very rich conversation. So thank you for your time.
Well, thank you very much for inviting me.
Thank you. Thank you. And thank you for watching our episode today. This has been your Campus Ministers on Air, signing out.
And there was another drive-by
The
shooting
fire we
today
reported at the old
downtown.
fire hall is still burning out of.
Do you sometimes feel confused or lost in the complications and complexities of life? Do you feel drained, listless, or exhausted from the daily burdens and responsibilities? Why not seek our Campus Ministers on Air every Tuesday from 2 to 3 in the afternoon? Listen to our counselors from the Loyola School's Campus Ministry Office as they ground our lives in our faith, in our school's spiritual tradition. Campus Ministers on Air. Be guided, be inspired, be blessed. Listen to our Campus Ministers on Air.